Have you ever stopped to watch ants build bridges with their bodies? It's a fascinating display of natural engineering, or been mesmerized by the sight of birds moving as one in the sky, a swirling, synchronized dance? It's not magic, it's teamwork, a fundamental principle in the natural world. And this very principle is inspiring a revolution in the field of robotics, pushing the boundaries of what's possible. Scientists are now asking a groundbreaking question. What if robots could work together with the same seamless coordination and efficiency as animals do? That's the core idea, the very heart of swarm robotics. Instead of focusing on building one super robot, a complex and often unwieldy machine, we shift our perspective and create many simple, specialized robots that can join forces, working in harmony to tackle big challenges. This innovative approach, deeply inspired by the elegance and efficiency of nature, is fundamentally changing how we approach problem solving. From enabling us to explore distant planets and uncover their secrets, to providing invaluable assistance and support right here on Earth. A single ant, on its own, isn't particularly smart or capable, but an entire colony can build intricate structures, defend its territory with unwavering resolve, and thrive in challenging environments, all by adhering to a set of simple, yet effective rules. When thousands of individual ants follow these seemingly basic rules, a remarkable and complex group behavior emerges, showcasing the power of collective intelligence. And that's precisely the secret that scientists are striving to replicate in the world of robotics. Simple robots working together to achieve big, impactful results. So, get ready to witness how nature's ingenious approach to teamwork is revolutionizing the field and shaping the very future of robotics as we know it. So what exactly is swarm robotics? It's a fascinating field that draws inspiration from the natural world. Imagine 100 or even 1,000 small, relatively simple robots, working together to move a heavy box, accomplishing something one robot simply couldn't do alone. It highlights the power of collaboration and distributed effort. Swarm robotics is fundamentally about groups of simple robots working together as a cohesive team, much like ants in a colony or bees in a hive. Crucially, there's typically no central leader dictating commands. Instead, each robot autonomously follows a set of basic rules, making decisions based on what it senses in its immediate surroundings. This decentralized approach is key, meaning the swarm can keep functioning and achieving its goals, even if individual robots break down or fail. The system is inherently resilient. Think of it like a crowd at a concert. There's no single person directing everyone's movements, but the crowd flows and moves together in a seemingly organic way. Each robot is constantly making small decisions, adjusting its behavior based on its neighbors, and yet, collectively, they create surprisingly organized and intelligent group actions. This emergent behavior is the real magic of swarm intelligence. Simple parts but incredibly complex and powerful results. Swarms are inherently robust, highly adaptable to changing circumstances, and capable of handling tasks that are simply too large or complex for any single robot to manage. The real power isn't in the capabilities of any individual robot, it's in the collective intelligence and coordinated action of the entire swarm, and that's the fundamental essence of a robot swarm. Nature's best engineers, ants and bees, show us how teamwork works. Ants use pheromone trails to guide each other to food, creating efficient paths without a leader. This indirect communication, called stigmergy, inspires robots to leave digital or physical markers for others to follow. Bees share information through their waggle dance, telling others where to find flowers. Robots mimic this by sending signals, like infrared or radio waves, to share discoveries with their neighbors. Information spreads quickly through the swarm, just like in a hive. By copying these natural strategies, robot swarms become smarter and more effective. Nature's communication tricks are now powering the next generation of robotics. What exactly makes a robot swarm so special and different from other robotic systems? What are the underlying principles that govern their behavior and allow them to achieve such remarkable feats of coordination and problem-solving? At the heart of every successful robot swarm, you'll find three core principles. Decentralization, meaning there's no single point of failure or central command dictating every move. Scalability, the ability to easily expand or contract the swarm as needed, adapting to the demands of the task at hand. And perhaps the most fascinating aspect, emergent behavior. There's no leader, no single robot calling the shots or orchestrating the entire operation. Instead, every robot follows the same simple rules, a set of guidelines that govern its interactions with its environment and with other robots in the swarm. and each robot makes its own decisions based on its local perception and these pre-programmed rules. If some robots fail, whether due to malfunction or external factors, the rest adapt and keep going, ensuring the swarm's overall mission isn't compromised. Swarms are scalable, meaning they can easily adjust to different task requirements. You can add or remove robots from the swarm, and the system still works, maintaining its functionality and effectiveness. But the real magic, the truly remarkable aspect of swarm robotics, is emergent behavior. Complex group actions and intelligent solutions that arise from simple individual rules. For example, a robot might just avoid bumping into others, a very basic and straightforward instruction. But when all the robots follow this simple rule together, the swarm forms complex patterns or explores an unknown environment efficiently. We don't need one perfect robot, a highly sophisticated and expensive machine capable of handling every task on its own. Instead, we need many simple ones working together, each contributing its small part to achieve a common goal. This approach is robust, meaning it can withstand failures and adapt to changing conditions, flexible and deeply inspired by nature's best problem solvers, from ant colonies to bee swarms and bird flocks. Swarm robotics is a fundamental shift in how we approach robotics, solving big problems, not with individual brilliance but with collective intelligence and coordinated action. That's the power of the swarm, a testament to the potential of distributed intelligence and collaborative robotics. Swarm robotics is already making a difference in the real world. In agriculture, swarms of robots can weed, water, and monitor crops more efficiently than a single machine. In search and rescue, tiny robots can crawl through rubble, find survivors, and signal for help, covering more ground faster. Warehouses use robot swarms to move shelves and manage inventory, speeding up online orders. In space, NASA is exploring swarms for planetary missions. Many small robots can map, sample, and explore more than one big rover. If one robot fails, the mission continues. Swarms are energy efficient, resilient, and adaptable. From farms to Mars, robot swarms are changing how we solve big challenges. The future is collective. For swarms to work, robots need to communicate, but not with words. They use stigmergy, like ants, leaving signals in the environment for others to follow. Robots might drop light beacons or markers to guide teammates. Direct communication happens through infrared or radio signals. Robots talk to nearby neighbors. Messages spread through the swarm, keeping communication simple and efficient. Each robot uses basic sensors, proximity, light, maybe cameras, to sense its local world. The Kilobot project shows this in action. Tiny robots use light signals to self-assemble into shapes. No central control, just local rules and simple messages. With these tools, swarms organize themselves into complex patterns. Simple communication, powerful results. Swarm robotics is promising, but not without challenges. Coordinating hundreds of robots in messy environments is tough. Designing the right rules takes lots of testing. Preventing robot traffic jams and interference is a big focus for researchers. Swarms must also be fault-tolerant. One robot's mistake shouldn't doom the group. Scientists are developing ways to detect and isolate faulty robots, making swarms even more reliable. Despite these hurdles, swarms are cheaper, more adaptable, and more robust than single robots. NASA's Mars research shows the power of many over one. The future belongs to swarms, collective intelligence solving our biggest challenges.